Now we are looking at the last example on the problems of the nature of the roots. This question asks us to show that for this expression, show that this expression will always have real roots for any value of k. All right. Remember that when we are solving problems relating to nature of the roots, the first thing we need to determine is the delta value, right? And we know that delta equals b squared minus 4ac, right? And this, the only time we'll be able to know what b, a, c are, we need to make sure this is written in standard form. So to do that, we will rewrite this expression again here. And remember that what we want to achieve is ax squared plus bx plus c. So the next thing we'll do is we'll put the 3 on the other side, right? So we have x squared minus kx plus plus k plus x minus 3 equals 0. And what we want to do is, remember, we want to achieve ax squared plus bx plus c. So we need to make sure we take out all the factors which have x squared and all the factors which have x. Here there's only one term which has x squared, so we'll write that neatly here, x squared. And then to factor out of this, right, we have x and x, so the factors are minus k and 1, and we have the x on the outside. And then we take also these two, we have k minus 3 equals 0. From this, we see that our a is that, our b is that, our c is that, right? So remember, our definition of delta is b squared minus 4ac, right? So we plug it in, we have our b here, b squared, from there minus 4a, our c is that, and we further simplify that. So if we expand this expression, this is what we will have. We'll have this term. If we expand this expression, this one, and if we simplify this, this is what we will have. And then the next thing we want to do is, firstly, remember that the question says that now we have simplified this, we have this expression. The question says we need to prove that no matter what this k value is, we will always have real roots, right? And we remember that for real roots, delta must be greater than 0. In other words, we need to prove that delta is always positive, right? So one way of doing that is by completing the square, right? Remember that we need to determine the nature of the roots without solving the equation. So now what we do is, when we complete the square, there's a specific procedure you need to follow, right? Firstly is that we rewrite this term as kx squared minus 6x, right? Firstly, what you want to do when you determine the square is you need to always make sure before you start determining the square that the coefficient of k squared, or rather x squared, is 1. And next is that you add half the middle terms squared, right? Do you notice this is, you add half b squared and you minus again half b squared, and then after that we have that 13. So do you notice that we still maintain that equation, kx squared minus 6 plus 13, and then we added and subtracted this. And if we add and subtract, the overall answer for this is 0. It has no impact on the equation, but it has an impact on how the equation is written down. So remember that completing the square, the procedure is specific. And then we simplify this. We know that this is 9, right? So it's plus 9, and here this is 9, this will be minus 9. So we write down a bit neat. We have k squared minus 6x plus 9, and here we add the 2, we add minus 9 plus 13, you'll get an answer of 4. So now we factorize this. When you factorize this, you'll see you will have k minus 3, k minus 3. We have plus 4 over there. And then we write this a bit neat. We have k minus 3 squared plus 4. Remember that we are required to prove that delta is always positive, meaning that we need to prove that the roots are always real, right? So firstly, in order to be able to prove that is we need to first show this. We know that what we need to write down what we know about this delta, right? We know that k minus 3 squared is always positive, and the reason being is that no matter what k is here, no matter this term will always be positive, because for instance, let's say we determine a value of k such that the final answer for this is minus 3, right? So minus 3 squared is positive 9. For instance, if again we plug in plus 3, 3 squared is 9. So it just shows that here this term, no matter what the sign is, this will be positive. So we know that this is positive. And then we see, right, if we add 4 to this expression on both sides, we add 4, right, on the left-hand side. Remember what we do on the left-hand side, we need to do on the right-hand side. And we add 0 plus 4, right? So we add 0, we add 4. So what we did basically, we wrote down what we know that this will always be positive. And then the next thing we did was we added 4 on each side. And how did we know whether to add 4? We are trying to form this expression and see what its effect is on the inequality, right? So let's rewrite this. We have k minus 3 squared plus 4. It tells us will always be greater than 4, right? So in other words, this will always be positive no matter what, because any value greater than 4 is positive. So in other words, we've proved that actually that delta is always positive, implying that roots are real for any real k. So we've proved it. So if you have any questions regarding this, you're welcome to ask me. I'll just write down my email address, or you can just comment on the comment section, and I can do a video later on further explaining this method.